Okay, I was trying to come up with a lesson plan for today, and I was talking with Eve the other day, and she said, Mr. Gant, she said, I don't feel like you're challenging us enough. And furthermore, Mr. Gantz, why don't you tell us when we're going to use this in real life? Like, for example, I would like to go into navigation. So, like, how could I use trigonometry if I work in navigation? I said, well, thank you, Eve. I can design a lesson for you right and perfectly based on that. Oh, wow. Okay. So, Eve is also an expert in reverse psychology. Okay. She's trying to psych you out right now, but good job, Eve. Good job. Keep that secret. You won't. All right. Two ships leave a port at noon. Ship A is traveling at bearing north 32 degrees west at a speed of 5, and then ship B is traveling at a bearing south 75 degrees east at a speed of 4. How far apart are they at 4 p.m.? Very good. They may not be able to see each other right now unless it's a maybe really crisp, clear day. All right, so the first ship is traveling north 32 degrees west. Where would that be? Right about there? Okay, all right, we're going to go 32 degrees. You guys are running the class. Good job. I've got another one, south 75 degrees east. Got a right there. And we are wondering how far apart they are. Eve, you okay? Good. It is a triangle. Okay, we've got ship A at 5 miles per hour and ship B at 4 miles per hour. How many hours have they been traveling for? 4 hours. Because they left at noon, it's currently 4 o'clock. They've been traveling 4 hours. So, who can tell me how many miles does ship A travel? 20 miles. How many miles does ship B travel? 16. Hey, I got two sides. If only I knew the angle in between those two sides. Wait a minute. What is that angle right there? What is that angle right there? 90. And what is that little skinny angle right there? 15. Hey, if I add all those up, I get 137 degrees. It looks like that is the included angle. What kind of triangle do I have? If I have side angle side, can I find the opposite side? How? What do I use? Law of cosines, which says d squared is equal to 20 squared plus 16 squared. So that looks like the Pythagorean theorem, right? And that's what the law of cosines is. It's just the Pythagorean theorem with a little adjustment. Minus 2 times 20 times 16 times the cosine of 137. That's the adjustment that we make to it. So 20 squared plus 16 squared minus 2 times 20 times 16 times the cosine of 137. Boom! That's my answer. Square root the answer. Okay. Do whatever you want. 33.53. Is that reasonable? What if I came up with 40? Is that reasonable? What if I came up with 10? Is that reasonable? You told me 40 was reasonable, and it is not. Remember your triangle inequality theorem? If this side is 20 and this side is 16, what's the longest that this side could be? It's got to be less than 36, right? So, yeah. So think of making a triangle here, okay? So Grace, suppose that this is a length of 5 and this is a length of 8, right? If these were completely straight, that would make 13, right? So if there's a little bend to it, then they definitely needs to be less than 13, correct? Yeah, so 20 plus 16 is 36, so it's got to be less than 36. Triangle inequality theorem, section 5.7 geometry. You guys used to rock that. All right, here we go. Example 2. This should be changed to 20. Plane flies 300 miles at a bearing of north, 80 degrees east. Last hour wanted me to do this, so I'll do it for you guys just in case that's where your brain is. Both bearings are in the northeast direction, so I just need to draw the first quadrant. We leave the airport. North, 80 degrees east. Somebody help a guy. Something like that? Then it's not a line. All right, so we've got 300 is that distance. Then the plane turns. There's a flock of geese in its path. Decides to turn. And it flies at a bearing of north, 20 degrees east. Yeah, there you go. For 400 miles. How far apart are they? Go! Somebody say something intelligent. It is a triangle. Good. Less than 700. Good. Find an angle. Good. Let's find an angle. What, Grant? Okay. Does not help me. Come on with something else. Okay. Right here? This one. No. All right. I will allow you to phone a friend. Natalie Day, go. Or you're phoning me. Yes, I do. I know how to find it. I think of when I turned. I was originally heading at a degree bearing of 80, and then I turned to 20. So therefore, I turned 60. So then what's this angle? Yep. I turned 60. The whole key is right here. Olivia, I was going 80. I turned to 20. So I turned 60 degrees. Yes, Eve. Makes a straight line, and a line is 180. All lines are straight. My bad. Makes a line 180 degrees. Linear pair. Supplementary. All right. Shoot. I got side angle side. If only I knew what to do with that. If only there's a flow chart that would tell me what to do. Boom. There it is. I messed it up. I got a plus sign here. It should be a minus sign. We all know that. $300 squared. plus 400 squared minus 2 times 300 times 400 times the cosine of 120. Got it. So we wrote it. 608.28. All right. Point A is due north of point B. Point C lies west of both. Yep. AB is 12. BC is 13. AC is 15. What is the bearing of C from B or B to C? C from A would be A to C. So if you see from, you can just switch that with 2 if you just flip them around. That's the way that works. Side, side, side. What do we need to come up with in order to solve this? An angle, right? Which angle should you come up with? Opposite the largest side, so B, 15 squared. Equals 13 squared. It's 12 squared. That's 2 times 13 times 12 times the cosine of B. If you haven't done this assignment yet, you might be confused on how to solve this a little bit. I subtract the 13 squared and the 12 squared over right away, and I get negative 88. I do negative 2 times 12 times 13, and I get negative 312. How do I solve that? Well, I get a positive or a negative. So does that mean I'm in the first quadrant or second quadrant? Acute or obtuse? Acute. $73.62. We're looking for the bearing of B to C. North, east, 73.62 degrees, east of north. Oh yeah, west, excuse me. Everybody's focused. You guys are much more awake than first hour. They were tired today. Same with third hour. Ooh, drew your triangle backwards. Unacceptable. It's probably due to your poor choice in clothing today. Yes. What? Oh, very good. Okay, so are you so you're bringing up the point that maybe C could be sitting here? Right. So we don't really know that until we solve for the angle. So the fact that we solve 73 degrees means that to go from here to here is 73. Suppose we would come. Right. Better? Good question. All right. Now I got to know A to C. So I should know angle A. What can I use? Law of sines. Is there any chance that A is obtuse? No. We don't need to worry about that situation at all. Sine of A over 13 equals a sine of 73.62 over 15. Hopefully you guys are super quick at using the law of sines now. $56.25. That's if we're given side angle side. We're given side side side. So we started by finding the largest angle. After that, it does not matter because there's no chance for an obtuse angle. Because these angles are definitely smaller than 73. Or just start by solving the angle opposite the largest side. And then you'll be good. All right. So, hey, now I'm lost. Okay, there we go. Back in the game, we've got, A to C is going to be southwest, and we turn 56.25 degrees to the west of south. Everybody good? All right. All right, let's skip example 4 and go to example 5. Example 5, you will have a problem like this on your test. It'll be worth 6 points. Your test is worth a total of 48. That means that this is 1/8 of the test, which means that this problem will count for 12.5% of your grade. So you need to know how to do this one. It involves all of the pieces of law of sines, law of cosines, and area. It's a wonderful problem. I love it, and I choose to teach it each year. So we've got a piece of land that is up against this river here. Okay, and we've been able to survey it and find out that this side over here is 285 feet. This side is 564. This side is 322. We have angles of 98 degrees. That used to be a band. And 105 degrees. This is just how we're going to set it up on the test. I will give those to you. I'll put them in place so you don't have to try to read my mind. That's not really fair. So, okay. Find the area. It's a quadrilateral. What's the formula for area of a quadrilateral? That would be a rectangle. Or a parallelogram. But not just a generic quadrilateral. How do we find the area? Make it into 2 triangles. Great idea. We know how to find the area of triangles. Or at least we thought we knew how to find the area of triangles. I mean, triangles are 1/2 base times height, right? Oh. What is it then, Rowan? Well, very good. Do I have AB and an angle included? So I could find triangle 1 area pretty quickly, couldn't I? .5 times 285 times 564 times the sine of 98. And I get 79,587.84. We're halfway there. That was easy half. Yes, very good. Very astute of you, Jackson. Now what? You want to find the side. Could make a third triangle. Or you want to make a 90-degree guy right here? Okay. Be nice to know theta, wouldn't it? In order to find theta, I might have to find alpha first. I have told you that story, haven't I? Yeah. Okay, here we go. I'll find C. How? Law of sines, awesome. Except you don't have an opposite side. Boom. Law of cosines. I know how to do that. I got C squared is equal to 285 squared, 564 squared, minus 2 times 285, is 564, times the sine. Oh, you guys are so smart. Cosine of 98 degrees. $25 squared plus 564 squared minus 2 times 285 times 564 times the cosine of 98. Is that the answer? Square root and you get Satan. Yes. Very good. I know. I didn't want to say anything. It was like, wow, it's like the irony. Can I now find alpha? How? Very good. Law of sine. Sine of 98 over Satan is equal to sine of alpha over 285. You can. You can. I believe in you. 285 sine of 98. 666.38. And I inverse sine 2506. How do I find the other angle? Yeah, 105 minus that angle. 79.94. I now have enough information to find the area of that triangle. Yeah, I got side angle side. 0.5 times 666.38 times the 322 times the sine of 79.94. And I get 105,637.68. I add the two together. $185,225.5 dose feet squared. Square footage is important. You guys probably, most of you live on a parcel of land, and it may have 4 sides to it, and it's probably not a perfect rectangle. So how do they calculate the area? Well, that's what you use. So we could actually go into program, and we could build a program that, given the 3 sides and the 2 angles, it would run through a series of tests and come up with the area. Once you wrote it, you would come up with it in a matter of 3 seconds. So if you want to write that program, go ahead. It's fun. It's a good time. What I'd like you guys to do is please take out your homework cover sheet first. And please also take out your study guide. On the homework cover sheet, you see that you have an assignment. It's listed there. It is a book assignment. I'm sorry I did not have time to make a worksheet. Okay, so you may want to take a picture of the book or whatever you need to do in order to see those pages again. But yep, and then it said no, I'm sorry, it's not online yet. It's not online. But here you have it says as you read the homework cover sheet that you should also find the area of a quadrilateral, and this is the quadrilateral that I'm describing. So if you want to write that on the bottom of your homework cover sheet or somewhere, that's the quadrilateral. You want to make sure that you have that done so we can check on Monday, so you can verify that you got it, correct or incorrect. And we'll talk about how close you need to get to the answer in order for it to be reasonable. The second one is if you look at your study guide, your study guide starts out, and by the way, it's only 4 pages. Your study guide starts out with what kind of triangles? If you look at the first couple problems, they're right triangles. Do you have to use the law of sines and cosines to do right triangles? You just use SOHCAHTOA. Just review SOHCAHTOA. Can you use the Pythagorean theorem? Yep. And then you got the law of sines and cosines. You got these triangles that you're going to solve, 6 of them. And you got the bearing problems. And on the back side, you got another one of these area problems. And so if you want to put these labels into there, 324, 500, 285, 8378, that would be good for you to do that. So on the back of your study guide, this is going to be question number 7. Again, please make sure that you know how to solve those type of problems. As I promise you will get them on the test. I will put them on the test for you. I just haven't gone back and made revisions to the study guide. First problems, you're given right triangles on the study guide. You can use SOHCAHTOA there.